For example, say that you want to create a counter and keep track of the number of times that you've called a method in code. To do this, you can declare the variable as static, and that's what I've done right here. Counter variable, it's an integer, it's private to this class, so it's not visible outside the class, but I'm in program.cs, so this is basically the top level code file. And I've declared it as static. And so now, instead of just having the lifetime of a single method, it has the lifetime of this class. So each time that you call the what time is it, the counter is going to be incremented by 1. So counter plus equals 1, and then I display the time string, and I've asked however many times. And then here's some code that is called from the main menu. It loops through 3 times and calls what time is it. And so each time this method is invoked, the counter variable is going to be incremented. And again, because it's a static method of the class outside the definition of a method, it's going to persist its value between method invocations. So if I run the code, static variable 0, it calls it 3 times. Notice it's in the evening, and it's because I declared that variable as static, it retains the value each time I call the method. Starts out 0, goes 1, 2, 3, incremented. Okay, so that's a pretty cool technique, but maybe something a little bit more practical. If I come back over here to the customer class, the class includes a static field called cumulative sales. And I can go to its definition right there. So as you can see, this is also, it's private to the customer class, so it's not visible outside the class. It's a static because I want the value to persist and be shared across all instances of the customer class. It's an integer, and it's going to record, it's initialized to 0, and it's going to record the cumulative sales for the customer. And then I have this record sales method, and pass in the customer ID, the sales, and the units. So it's going to record the amount of the sales and the number of units. And it's once again going to write out an XML file. So I use the XML writer settings to make it human readable. I create an XML writer. I'm going to put it in the Learn Now folder, and then I'm going to build the XML. So pretty typical XML way of, or techniques for building XML. And the .NET Framework has a lot of different ways, very rich, robust support for creating XML just about any way that you could possibly want to. Okay, so I start by writing customer sales. I write the string customer ID. I write the sales. I'm going to convert it to a string, whatever that number is. And if the units are -1, it's going to say that the units are unknown. Maybe I have some sales, I have dollar sales, but I don't know what units are involved. Otherwise, it's also going to write out units. And then it closes everything down and then adds that number of sales to the cumulative sales. And so it's going to, again, all across all instances of the customer object, retain that cumulative sales value. Now, cumulative sales is private to the class. So there's no way for external code to see that. So instead what I have is a total sales method right there that returns, it's read-only, and it returns the value of that cumulative sales. And because it's read-only, there's no way to use this method or this property in order to update the value. The only way to change cumulative sales is by calling that record sales method that I just showed you. Okay, so here's some code that shows how you can use that. So I new up a new customer. I'm defining the units as 500,000, 500,000, and amount as, looks like 100 million. And I call the record sales method of the customer class. And I pass in the customer ID, the amount, and the units. And that's going to update the number of cumulative sales including to write out the XML file. Because again, remember, record sales, if I go back to it, is writing out that XML file as well as adding to the cumulative sales. Okay, then I'm going to change the units and the amount, call the record sales again, and this is going to be associated with the small customer, and display the information there. And then do it once again, record the sales, and display that information. And then finally, once I'm all done, use the total sales property in order to retrieve the total amount of the sales and format it as currency. All right, I'll run that code and select P. And there you can see the order one amount. There I have the nice separated so I can see it is in fact 100 million, 10 million, then 1 million. And the total amount is 111 million. And that is just reading that cumulative sales static variable using the total sales property. Okay, so a pretty nifty technique. Now, by default, the properties and methods of a class belong to an instance of the class. This means that you can't use a property or method of a class in code unless you first create an instance of the class. And those kinds of properties and methods are called instance members. You can also call a static member, on the other hand, without first creating an instance of the class. And an example of that is the WriteLine method of the console class. That's a static method. You can just type console.WriteLine in your code and pass in a string to display. You don't have to instantiate the console object. And you can do the same thing. You can create your own static properties and methods by using the static keyword. All right, so if I go back over here to customer, I have a getCustomerName method here. Okay, so what this does is it takes a customer ID and goes out, opens up a connection to the file, the customer information file, and then reads the customer name information. So all it's doing is it's going to retrieve the customer name string. It's just one piece of information that we want from the file. That's the name of the method, getCustomerName. All right, and then it returns customer name. So it returns a string. But what's interesting here is that because the code doesn't reference any properties or fields of a current instance of the class, I'm not reading the backing fields, I'm not reading any of the properties, I'm not calling any other instance methods, I'm not using anything within the class itself. Most notably, it doesn't use the this keyword. There's no need for a current instance of the class. All right, so that's a necessary prerequisite for making a class member static. So I don't need an instance of the customer object in order to use this method. I can just pass in the customer ID, it'll go out, get the customer name, and return it, and I'm done. Okay, and here's some code that shows how to do that. I'm just using the class name. I don't have an instance of the customer class. I call that method, say, and pass in the customer ID, and that returns the customer name. Now, strictly speaking, throughout all of this code, I'm focusing on the C# features. There's lots of things that can go wrong. I should be handling exceptions. I should make sure that the calling code actually passes in a customer ID and so forth, but I'm keeping the code simple. Okay, so I get the customer name, and it writes that out to the console. And when I run it, want static methods, Q, and there you can see customer Biggie is Biggie Industries. All right, so I didn't use an instance of the object at all.